All right. So today what we're going to do is we're going to begin our look at annuities. And so we want to define that loosely. An annuity is a type of investment where you pay in money for a certain amount of time and then you withdraw money. So think like superannuation. Superannuation, your employer makes a deposit every month for you, and then when you retire, you withdraw that money. Okay? So there are two phases for every annuity: the deposit phase and a withdrawal phase. Right? All kinds of different annuities out there, but that's the basic idea behind it. And what we're going to do is we're going to look at how to determine the future value of an annuity. And the good news is that future value of an annuity is much like future value of a reducing balance loan, future balance of an investment. So they use, for the most part, the same formulas. Okay? So what we're going to do is we're going to look at three different cases for future value. And the one that you're going to choose, the formula you're going to choose, is going to be determined by the information that you're given in the beginning, right? And boil it down pretty quickly and easily. First cases is if you start with a zero balance. So let's say you start a new job, your employer is going to put in $1,500 a month into your superannuation, so you're starting off with nothing, right? Okay. If that's the case, then there are two formulas that you can choose from, and they are going to look very familiar to you. The first one is if you're looking for over a short time period. If it's a short time period, say 3 compounding periods, 5 compounding periods, something like that, then we can just use that recursive formula just exactly like we did for reducing balance loans. So, remember the formula. The initial value, A sub 0, which in this case, of course, is always going to be 0 because you're just starting. The next value can be found by taking R times the previous value, but here's where it goes a little bit different. Plus or minus D. All right, so A sub 0 means the initial value or principal. We've done that 1,000 times, and in this case, because you're starting with 0, that's always going to be 0. A to the n plus 1 always means the next value, so the next value is equal to R, which remember we've used R before. R is simply 1 plus your I, and you can formulate your I depending on the amount of interest that you start with and how many compounding periods. Now the difference is this plus and minus, that's new, and that's because with an annuity you have a deposit phase and you have a withdrawal phase. Okay, so you get a plus or minus again because you have a deposit phase and you have a withdrawal phase. So that's why you get plus or minus. It depends on the question. Are you depositing or are you withdrawing? And that's very similar to what we did with the investments that we started with. Remember, we started off with adding money into the accounts, investing money into the accounts, making payments, that kind of thing. So plus or minus, again, it's very self-explanatory which one you're going to need. And the D stands for either the deposit or withdrawal amount. So that's how much, say, your employer is putting into your superannuation, or it's how much you're taking out per month when you retire. Okay? So D for deposit, but it can also mean withdrawal. Okay? All right. Now, second case. Again, this is if the balance begins at 0. If the balance begins at 0 and you want to see what's happening over a long time period, then we're going to use the formula for future value of an annuity, which you've seen before. We used it as part of the reducing balance formula. Future value is equal to M, which stands for either the withdrawal or the deposit, depending on what you're doing, times 1 plus I raised to the nth minus 1, all divided by I. And we've talked about each one of those pieces when we used this piece of that formula before. So that's exactly the same thing. It is literally the future value for an annuity. And what it does is it represents the value with change happening, right? Whereas compound interest is consistent change. This is a change that has changed. So the change is not automatically just one amount like it is in compound interest. With compound interest, it's all ever changing depending on if you're withdrawing or depositing. So, okay. Then the third case is if the beginning balance is not 0. So say, for example, that when you graduate from university and before you get your first job, your grandmother sells her Harley Davidson and gives you 20 grand. All right? So you have that amount of money to start with. So you put that in the bank, and then your employer is going to put money on top of it. Right? Okay? If that's the case, then what you get is a combination.
Sorry, sir, can I borrow Peyton Johnson for a minute?
Right. And the combination of formulas that you have is going to look very familiar to you because it's exactly what we did last class. The future value of an annuity starts with just compound interest on the initial amount you deposited. So P times 1 plus I raised to the nth power. We're still going to have plus or minus. Plus if you're in the deposit stage, minus if you're in the withdrawal stage. And the rest of it is, the rest of it is the future value of the annuity. So M times 1 plus I raised to the nth power minus 1, all divided by I, close your bracket. So those are the three formulas that you're going to be using to find future value of an annuity. So you've got two things that you need to determine. First of all, what is your beginning balance? Is it 0? Then you have your two formulas for that. If it's not, then you have the one combination of formulas that you'd use. Second thing you need to do is determine, are you in the withdrawal phase or the deposit phase? And let me tell you that most of these questions give you some where they're depositing and then they start withdrawing. So you have to watch your timing when you're looking at these. And we're going to look at some examples for you. But you really have to pay close attention to what the question is asking and the details of the question. So these can be tricky if you don't slow down and pay attention. Okay?